So, hi everybody, my name is Jan. I'm from Ptui and currently I'm the lead iOS developer at Databox. Databox is a mobile business intelligence platform, and we basically focus on mobile analytics, and currently we're also hiring. So if any of you is interested, you should talk to me after the presentation. And today I'll be talking about mobile push notifications and the mission to make them as reliable as possible. So most of you are already familiar with push notifications. They are those annoying little messages, sounds, badges and stuff that pop up all over our applications or devices when we least expect them. But they are a way to send information to our users, and that is an important feature. So in a way, they are actually the very meaning of real time. Well, the question you're probably already asking yourself is, why should I care, right? Well, the reason is because most software being written today has a mobile application at the end of the data flow. So pretty much any piece of software has an application or at least a website at the end. So push notifications, they drive adoption, they make users stick, they provide data. They provide data at real time. So yeah, they are really useful. And the problem with them is, well, that they don't work, at least not always. So that's why we're here for today, right? So our goal is to get the notification across, and in addition, we also want to know when a device got a notification and which notification did it receive. So let's look at the three usual suspects in the today mobile market. So first up we have Android, and then we have iOS and Windows Phone. Well, why the hell not? So all the three platforms offer a push notification service. So our backend servers can send requests to the notification providers, and they will dispatch notifications to our devices. And well, the problem is on the third line, where it says no confirmation. And on Android and Windows Phone, we can get feedback in a way that the server will tell us if the notification was sent, but there is still no end-to-end delivery confirmation. So that's a problem. And it turns out that Android and both Windows Phone are solvable. We can solve this problem with a background service. So each application can have a service that runs in the background, and each time a notification gets across, the service can wake up and send some data back to our server. But with iOS, things get a little bit trickier. So we'll be focusing on iOS today, and there are two reasons. Like I said, they are tricky, and secondly, well, because I'm an iOS developer. So the service that Apple provides is called the Apple Push Notification Service, and the documentation has a section called Quality of Service. And it says if the device is offline, the push notification service will store one notification for an application, and it will store it for a limited period of time. It will store only one notification, so if the device is offline and we send 5 notifications, only one will be cached, so that's a problem. And if the device remains offline for long enough, it will discard that single cache notification as well. So here's the typical registration flow with the Apple Push Notification Service. The steps we're actually interested in is the third and fourth. So the device says it wants to register to receive push notifications, and that's the time when you get that annoying little pop-up in the application asking you if you want to confirm or reject. And if the user confirms with push notifications, the client application will receive a device token, which it will then send to a backend server. And while the push notification flow is pretty simple, the provider sends the device token along with some other data to the Apple notification service, which then dispatches the notification to our device. And well, I will try to demonstrate the problem by, okay, so I've put together a really simple script. It's all hard-coded, and the idea is to demonstrate that not every notification will come across. So what I have here is, just a sec. Okay. Come on. Oh, almost. Perfect. Okay. So this is my device, and I will now try to send it a couple of push notifications, and let's see what happens. Okay. And here's the device. Okay, the first one got through. Okay, we got 3, 4. Perfect. We got all 5. But well, this isn't always the case. So this is a screenshot where I didn't get a notification. So this is a problem, right? And well, we want to solve it. So I was talking. The title of my talk is that we'll be in a hunt, right? So let's begin. And a good place to start is the documentation. And the documentation says that iOS actually supports 2 types of notifications, and they are called the remote notifications and local notifications. The remote ones are dispatched from the Apple push notification service, and they require a device which is online. And in contrast, the local notifications are scheduled on the device itself. So me as a developer, I can pretty much hard code a notification and say I want to fire it in 1 hour, and the iOS will take care that the notification gets delivered. So it will work just about everywhere. And well, if we dig deeper into local notification, well, the problem with them is that on the device we don't know what really happens somewhere remote, but the provider does. And if we dig a bit deeper into the documentation, we can see that each remote notification, so the notifications that the Apple push notification service sends, have a set of predefined fields, and one of those fields is called content available. And well, that is a pretty promising field because it says that when we specify content available flag in the push notification payload, the iOS will wake up the application and give it a 30-second window in which the application can sync with the backend server. So progressively thinking, this is the time that we could actually ask our server, do we have any data we need to display to the user, and the server will respond, and if there is any, we can schedule a local push notification, right? So we will have a confirmation that we actually successfully scheduled a local notification. But well, in order to do that, we must specify some additional settings in our application, but that isn't a problem. So the solution to our problem is we want to remove the Apple push notification service as much as possible. So we will do it by using silent notifications, which are still remote. There is no way around it. We will use a synchronization procedure, which will then take care of local scheduling of push notifications, and we will also provide a feedback to our backend server. So before we jump into that, let me talk about a few application states an iOS application can be in. So there are a number of states, and the problem is with the first and the second state. So these are the states when the application is not running and it was either killed by the user or the system hasn't launched it yet. So this is the time when we can't get any notification across aside from the normal remote notification. So the content available flag will not wake up our application. It won't do anything good. But with the other states, we can actually improve the push notification delivery by a pretty decent amount. So the synchronization procedure I mentioned, it will be a generic procedure which we will use all around the app, so it doesn't have to be in background. It will provide us with a full duplex communication, which removes overhead, and it will be usable for more than just notifications. It can also be used to transfer data. So the technology we'll be using is WebSocket. It's a very cool solution. It can be employed on a number of devices, and what it provides, it provides us with a full duplex via TCP socket. It's compatible with all your existing HTTP REST APIs. It's an independent protocol. It works via the port 80, so there are no firewall issues. And it also has a secure mode, which is a neat little feature. So this is the recipe. We will use a simple custom protocol on top of the on top of WebSocket. We will use WebSockets for server-side pushing, and when the connection is active, the server will push as much pre-known data as possible. And the application will then simply schedule push notifications locally, and it will provide server with the feedback that the notifications successfully got across. So there are a number of benefits we get by doing this, things this way. So we have also much better control over local notifications. We can cancel them, and we are 100% sure that they will actually be delivered. So this is the example of the protocol. It's a very simple protocol that will be used only for demonstration purposes. So the first 3 letters will identify our protocol. So if we have anything else on the socket, we will know where to dispatch it. And then the method can be used to schedule or cancel a notification. The type will currently only be a notification. Then we have a fire time, the title string, and the body string. So that's it. So enough talking. Let's show some code, right? So I have an application ready. There we go. Okay, I have built a demo application, which is right here. It's nothing fancy really. What we're more interested in is the debugger console, which is right here. So the application itself is pretty simple. We have an API client which uses a WebSocket, and it tries to open the WebSocket as soon as possible. So as soon as the socket is opened, we can use it for full duplex communication. And as soon as the application gets launched, we will try to open the socket. And here are a number of callbacks that the iOS will send us when we receive notifications. So the ones we are interested in is this one. This one will be called when a local notification is delivered. So a notification which was scheduled on the device itself. And here are some other callbacks which will get fired when we receive a remote notification. So as you saw earlier, the remote notifications did get across, but there was no proof that the client actually received them. So I have another script here, which is a very simple a Ruby WebSocket server, and as soon as a connection gets open, it just listens for stuff from the keyboard, and we can schedule notifications from my Mac. So if I run this, okay, so now the server is running, and now I'll run the application. Okay, almost. Okay, here we go. So, okay, we received a callback that the socket got opened, which is cool, and that is also visible here, so we can. Okay, so I sent hey, and the device received hey, and that's cool. So the socket communication works, and now we can use our simple protocol to schedule notifications. So. So what this will do is it will schedule notification with title test, and the body will be test as well, and it will schedule it 5 seconds after the device receives the message. Whoops. Well, that's not cool. Just a sec. Okay, so the socket got opened again, and now. All right, so what? I'm sure this works. I mean, I tested it a few minutes ago. So, okay, let's try it again. And well, this is odd.
Did you forget the number? The 5 seconds?
Yeah, that could be the issue. Well, let's see. Yeah, that was probably it. Oh, come on. Okay, let me just hard code it real quick. Okay, and then I'll run it again. Okay, it should work now. Hopefully. Okay, so the socket is opened. All right, so we schedule a notification and well, the device. Okay, so it received a notification and we can see it got locked in the debugger console. So the proof of concept works, and we can see all is fine when the application is in foreground, right? So now the application is in foreground, we have an active connection, and that's cool. But what happens if I put the application in background? So now the socket connection got closed. We don't even know that, because as soon as the application goes into background, the IS will kill just about anything related with the application. So what we can do now is we use a different type of notification, which I mentioned earlier. It's a silent notification, and we just need to specify the content available flag. So if I run this, like so. Okay, so we got a remote push notification saying content available, and the application, the socket received a message. I just hard-coded some stuff. I just hard-coded some stuff that as soon as we get a silent notification, the WebSocket connection will establish again, and the device will just say a message saying app reporting from background, and the WebSocket server will respond by scheduling a local notification, which we can see here. And as we saw, the notification actually got delivered. So if I run it again, and okay, so here's the notification. Now it got scheduled, and if I wait just a little bit, sure enough. So now I can be sure that the device actually received a notification. And furthermore, we can also use this procedure to synchronize data in background and to do other background related stuff as well. So the profit is, I mean, our mission is pretty much accomplished, right? The only problem we have left is when the application is killed. Unfortunately, there is no solution to that problem just yet. We pretty much can't do anything if the IS kills our application. But this is a working proof of concept how we can at least be sure that a notification actually got across. So, in conclusion, the Apple Push Notification Service is a very powerful tool if we know how to leverage it properly. We still can't reach the clean 100%, but it's definitely a lot better than the push notification service alone, since we know which notifications were received and when did we actually get them. So, here are some success rates. If we use a brute force for loop and we send a bunch of notifications to the Apple notification service, the success rate is around 95%. And if we use the content available and use the custom synchronization procedure, then every notification will get across. And well, in real world scenario, there is still no definite percentage I can give you. It's definite that the custom synchronization is at least as effective as the push notification service, and oftentimes it's a lot better, but we still can't get to the 100%. So we could improve this further. Another flag we can specify is we can set an application badge number from the push notification. So we could use like I think it's like this. So if I specify this and try to push it, oh come on, oh yeah, okay. Okay. So I set the badge number, and if I had the same, and if I had a number of badges which mark unread notifications, also cached in the application locally, I could then subtract one from another and see if they are equal, then nothing new happened. And if they aren't, then some activity happened. We could say we got 3 notifications, but we couldn't say which which 3 we actually got. So that's an improvement. And more improvements, we could also use more background modes, as I mentioned earlier. So for instance, voice over IP applications are allowed to wake up for 30 seconds once every hour. So that's an improvement. And yeah, silent notifications, like I mentioned, can also be used for data synchronization. So that's it from my part. If you have any questions.
So silent notifications are delivered by Apple push notifications?
Yeah, they are still remote, yeah.
So why are they more reliable than just a typical push notification?
Because when a silent notification arrives, the IS will wake up your application, and then you can do a background synchronization, right? So if you send a silent notification and you don't hear from the application in a few seconds, you can assume that it didn't get across.
Yeah,
It's not more reliable, just try it.
Yeah, you can't force the Apple push notification service to deliver the notification.
the reason that it fails, the push notification service?
Most of the times it's because you send too many notifications at once, or the device is not available, or it can be pretty much any reason. I mean, there's no definite feedback you can get from the notification service saying what went wrong. So yeah, you don't know, basically.
They basically just need to improve that. And
Yeah, pretty much. I mean, it is a pretty reliable service, but if you have like a chat app or something like that, you're aiming for 100%, right? And if you have a chat app, it's usually in the background, so it didn't get killed. And in that scenario, you can have 100% success rate if you use silent notifications and local scheduling. I mean, something like it. I mean, you use the remote notifications only as a way to wake up your app, and as soon as the app is woken up, you then try to synchronize and schedule local notifications. So that's the idea. You want to remove the Apple push notification service as much as you can.
Are you worried about making this battery life worse because you are establishing a connection back to your server?
Sorry?
Are you worried about making your the battery life worse because you are extra connection?
Yeah, I mean, the iOS itself is pretty good at battery management, so the maximum time the application can run in background is 30 seconds, so this is not nearly enough time to drain the battery, and when the application is active, it's not a very noticeable impact on the...
I don't mean draining, but like it probably has an effect, right? Still more than 0?
Yeah, definitely. But I mean, it's not critical in any way. You can't even notice it. So.
And then I saw that the notification has about 30 seconds.
Yeah. You get a callback. This is a file called application delegate, and the application delegate, well, it's basically a bunch of callbacks which the iOS calls on your application, right? So this particular function gets called as we receive the silent notification, and it also passes something called a completion handler, which we call as soon as we finish our synchronization procedure. So in this example, I'm not sure, can you see it clearly, or, I mean, is it readable? Okay, just a sec. Okay, so it's probably better now, right? You call this completion handler as soon as you're finished synchronizing. The iOS will kill your app after 30 seconds, but that's usually more than enough time to get stuff across. I mean, most requests take about 2 or 3 seconds, so yeah. Okay, anything else?
Was it worth it to build all this from 5%?
Yes, it was definitely worth it, not just from the push reliability aspect, but also you can use WebSockets for server-side pushing. So, I mean, Databox is aiming to be a real-time app, right? So, as soon as anything interesting happens.
But if you're preloading, then you're not pushing real time. Aren't you preloading notifications?
If you can. Yeah, I mean, if something real-time happens, then you try to send a silent notification, and then you confirm the delivery by scheduling it locally. Yeah.
Is there a limit of silence notification wait for an hour or something like this?
Not that I would know of, no. I mean, the push notification service is pretty picky, so it can reject the notifications if you're like over spamming it, and also the IS itself will notice if you like try to wake up your app every couple seconds. If you want to like be that real time, you probably want to look into other background modes. So there's also one called remote. Let's see, I can check it. So yeah, these are the background modes. So I can also use the background fetch mode, which tells the IS to learn how the user uses your application, and it will then predict when it's the time to like wake it up, and IS will pretty much wake up your application randomly and allow it to sync for a minute or two, something like that. So yeah, and then you can also use the voice over IP mode, which is a little bit trickier to get accepted on the Apple store, but when you have a voice over IP app, you are bound to get at least one window once every hour, so you can use that as well.